our next speaker is Letian Wang. He's the VP of Product at Robot Era. They're a full-stack robotics provider, and I'm excited to hear exactly what they have in store. So please give them a warm welcome. Thank you.
Just clicker.
There you go.
All right. Great. Hi, everyone. My name is Letian, or you can call me Lucas. From specs to sweat, that's how I want to talk about, to put robots and humanoid perform in China. So a little bit about our founder, Jianyu Chen. He's right now AP in Tsinghua University, under mentorship previously from Professor Tomitsuka and also academician Yao Qizhi. He's really an expert in both AI algorithm and hardware from his previous experience, and also recent papers in RSS 2024, we get generalized working for humanoids, very recognized. And also the manipulation work getting recognized in SAML 2025. Please look it up. Okay, so about our products. We have full-size humanoids, including the bipedal, upper body torso, and wheeled, and also 5-finger dexterous hand. We have 12 very famous XN1 12-degree freedom and XN1 light. And also a little bit perk about this previous summit is that I'm holding our next generation XN1 Pro with 21 active degree of freedom, all in position. So you're welcome to drop by in our booth later or catch me up and we can talk about this a little bit more. All right, let me put this a bit right here. So that's our idea. Okay, sorry. Okay, get this whole thing up. So we are a full stack company, and we are bringing our brand Era 42, including end-to-end VOA word model and reinforcement learning. And we are attacking 3 markets. Number 1 is 2A. We get to the research institution and the tech corporate. And we get a tremendous product feedback from this market. I won't mention just a few of them, that's our customer. And 2B, we are attacking manufacturing and logistics, including internationally and domestically. And also, access to applications is actually to B2C companies, where they're serving the customers directly. And it's like Lenovo, Haier, and Ant Group, which is part of the Alibaba. And that's part of our logo right here. And 9 out of 10 world's top 10 tech companies, our clients, and more than 500 units have been delivered, and more than 700 orders. And number of repeat purchase had been exceed 4. And here is our very important announcement today, is our recent breakthrough in the VOA model deployment. Oh, sorry, POC in logistics. Please view. Is there any sound? But it's fine. Yeah, maybe a bit sound will be nice, if that's possible. Yeah, that's built in a real warehouse, connected to the information system. It's right now going orders. You see the medicine is inside this box and transporting with a trail towards that robot. So autonomous picking the item up, failed, and pick it again, and rotate it, scan the code, put it back. It's a very important part of medicine transportation, as you probably know. We need to verify whether it's authentic or counterfeit. Scan the verification. All right, thank you. And this is connected to the information system. The order has been completed. So this is digital twin in the screen. High frequency reasoning, we use a small model. We are not really aiming for generalized VOA. So that's getting really fast. So now we'll deploy 2 robots in a scene. They're doing different tasks. Thanks to our dexterous hand, you can do versatile tasks, including this time of trail or box. And this is our training field in our lab, where you already train this model to be collaborating, and these are the real tasks. Of course, the speed can be improved further, but that's really showing the way we're going. Great. So that's the key breakthrough we are trying to announce today. And we will be having, and also a very important message I'm trying to deliver to our customer, potential partner, is that we're really here to provide hardware and tool chain, and also help customers' model to perform. So we're trying to really be friends to our customers, not really to compete. That's a really important message I'm trying to deliver. Okay, so if you got more minutes, I will be introducing our products one by one, and that's our full-size bipedal humanoid. It's there's some video. Let me show. Thanks to the torque we are providing from this big hip, giant hip, it goes through 360-degree rotation, and also doing hip-hop dancing. I think it's a breaking, probably. Dancing is really hard to be, manipulated in terms of video editing. So we put it this way: there's no way to edit it because it's continuous movement. Oh, it's a little bit. That's our lab. We are training this model separately. Actually, you can use our upper body torso version. We call it M7 to do all the training. And we use vision and also manus-based type of data collection system. These are being shown. So this is your sorting package based on different materials, package, metal, paper towel, tissue. And there's a little bit human interference. It's fine, no problem. And actually we show this in real time in China's WRC demo. It's using tools, folding. Apparently, we didn't train extensively on the folding, so it's just a very simple demo. So the width has 3 degrees of freedom, very versatile. And this is running at maximum 4 meters per second. Yep. So 2 models, and that's just some basic data. We built our own modular in-house, had 400 Newton meters. Okay, everyone knows that there's a very interesting Olympics in Beijing for robots. So we are champions for, that's a bit little, but horizontal jump and vertical jump. So thanks to, again, the giant hip L7 offers. Yeah. Okay. Very early, or a bit earlier, last year, we're doing some POC in the factory to moving this whole thing. But we don't really carry this through just for, there's more algorithm development involved. So we shrink the scope a little bit more just to the logistics, so it's easier to deploy our VOA model. And this is M7, which is our upper body torso. We want it to be the #1 stop for people who get into the humanoid. You know, it could be painful for you use a gantry to manipulate a bipedal humanoid. It could be painful for use the wheel because still requires additional navigation algorithm. But it could be just very simple, like installing a upper body torso in a fixed position in your plant. It could be logistics, it could be factory. And also for good for research, right? And we have 7 DOF humanoid, well, that's normal right now. And we offer our own Dexter's hand, X hand. And also the cross-axis wrist is really, really good for human-like wrist, just like human. And this 2.1 meters working space is still just considering the hand right here. But if you consider there's 3 DOF wrist right there, the working space could be much larger. And we already showed this breakthrough in our logistics VOA deployment. Different sites in China, Zhejiang, Shenzhen, different sites. Okay, so I've introduced our humanoid for work and really powerful work, and now it's Q5. We think it's a little more like female-like type of shape, and we want to introduce good feelings about robots. One video was showing you how Q5 is approaching this differently. Has 44 degree freedom, 2 arms, with zero vision and also very slim wrist. It's right about this big. It's right now using the X1 Lite with lower degree freedom but much more slim look. Give you very female, or sorry, my bad, very human-like feelings. So we imagine it could be very useful for mall, for guiding. Of course, there's a bit more work that needs to be done to cleaning the shoes for people, but that's our vision. 1.5 meters per second. A much more surprisingly important usage is for tourism. Now, everybody likes to take pictures with robots, and everywhere there's a line for it. It could be used museum, school, and even at home. Just look at how these robots fit in this whole environment setting, thanks to our ID design. And we offer our house build the tool chain for data collection. And very soon, next quarter, you'll be able to use this system to collect your own data and even train your own model. All right, so we approach this differently. I will skip this for faster. Last is our very important factor is that our Dexter's hand. We have X1 Lite with 6 active DOF and 11 in total, and X1 12 active DOF. Very few companies using 12. And actually, X1 is right now become in the number. There's a block right bottom. #1 total sales in high degree of freedom hands outside China. Because in China, there's lots of suppliers and selling very, very low price, very, very low quality hands to companies. But outside China, right now, we're probably #1 total sales. Yeah. And X7 Pro is right here. We are still working on it. It's our prototype, but it has 21 active degree freedom and 4 tactile coverage, which no other competitor right now offer in this market. It's covering everywhere, including this fingertip pad here, 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 here again. All right. For XN1, let's forget about this. There's a key things. So high resolution tactile sensors, 270 degrees coverage. And for the direct drive here, bear this with me, sorry. There's ambiguities. In humanoid field, people say direct drive is without any reducers. But in the dexterous hand, because direct drive is a different way to showing that there's only gears, there's no linkage, no tandem to be actuation, to be transmission. So we use the term direct drive to showing this. And 12, very powerful grip, very fast response. There are some videos showing this fastness. Can I play it? Okay, cool. 10 clicks per second is professional gamer's speed. It's powerful. We can use current for force control without tactiles, current-based force control. And it's very compliant. Ultra low damping. Very smooth backdraft ability. The three-dimensional tactile sensing. And we offer teleoperation suits. Not only Apple Vision Pro, it's early in this year. Right now we offer Meta Quest, Manus Pro as well. And even exoskeleton like Dougal. This is fully teleoperation. The size of a hand. Awesome. So XN1 Lite, which we offer for more like a less dexterous tasks or low-cost tasks, and also tasks that requires better appearance, form factor. And it inherits the same advantage compared to the XN1 in terms of direct drive. So different from some of the offering in that across the whole from Inspire Hand, it's direct drive, so you can back drive it. And adoption, the reason that there's a video from Humanoid AI, we just very accidentally noticed that, oh, actually our hand is in their PR video. That's what very, very interesting. And of course, the AI, Unitree for sure, lots of other humanoids. And that's our ecosystem. We designed this product to be really AI friendly, so we offer simulation and data collection in terms of vision and Manus, and offer also the force control, not only the tactiles, but also current-based force control. That's the advantage of a direct drive type of performance. And also the research paper is coming just recently so much that I cannot list them all. So it's including the IOS data collection, and the ROS simulation, and the VOA word model, every different objects. And even someone had an open source project for connecting Xhand with Franca. That will be the talk of today, and we're happy to take some questions. And you're welcome to find me in LinkedIn or look me up in Lucas Wang X, in the X.
Thank you, sir.
Thank you.
We do have time for probably 2 quick questions. Are there any questions from the audience? We have one right here, if we can get them a microphone.
So in the Skilled AI talk yesterday, the presenter mentioned that all the demos of humanoid robots, they don't show the robots climbing stairs or climbing terrain. So I just throw the same question back to you. Are you able to show that? Climbing stairs or climbing terrain? Climbing hills, climbing stairs.
Oh, climbing hills and then climbing what?
Stairs.
Stairs.
Staircases.
Like these.
I guess I didn't put that. Maybe I can go back a little bit. Can I go back? The first slide. So you're welcome to look at the paper we showed in the. Damn it. Sorry. in the RS 2024, in there, we're showing the robots climbing the stairs and also the hills, because it's just 1 year ago, and even 2 years ago when we actually did it. So we didn't to show this. Thank you.
We have time for one more question, I believe. We have one right here from...
Hi, thank you for the presentation. I have a question about the robustness of hands. Do you already have like curves which show, well, how robust are actually the hands? I think that's the question a lot of people are asking ourselves. Well, how many cycles can you do, for instance, when lifting up 10 kilograms or 25 kilograms? Is this something that you're considering? Because I think that could also be very good marketing material in the future when you have that.
Sure. So I think of this problem as a way how to describe the usage. So what we look at this, we want it to be resilient to the impact loading, because normally when you do teleoperation to collect data, there's a lot of impact loading right there. But there's not really a lot like carrying a box for like 10 minutes, keep it there, right? So if we put it this way, then what we are doing right now is designing for developing the AI models for work. So in that way, you don't really care too much for duration of the loading. You really care about the impact loading. So that's the number one thing I want to talk about. And number two is really about like you need to care about the payload, right? So lots of our competitor or our other offerings, they're talking about like, hey, our hand can go like 1 million times without loading. It's just like saying, hey, my car can drive 1 million miles on highway, right? But you never drive highway for that long, right? You're driving very, very bumpy ways. So it's just like what we do in the teleoperation. So that leads to one very key feature in our hand is like direct drive. It can back drive. So that offers really impact resistance and very, very less likely to be broken.
Great.
Yeah, if I understand.
Thank you for your questions. We're out of time, unfortunately, but thank you so much, Letian. That was a great presentation.
Thank you.
Super excited about what you're up to.
Appreciate it.
Thank you.
Thank you.